Okay, today in IM1 we're going to talk about functions. So first we're going to talk about relations. A relationship can be represented by a graph or a set of ordered pairs, x, y, and those are called relations. A function is a special kind of relation. So you can see that the x, y is represented in both of these, and that represents the relation. Okay, on a graph it would look like this. So we can see that it is a bunch of dots, but here's 4, 7 right here. So right there is 4, 7, and the other points are also represented as well. So let's look at an example. In the scoring system of some track meets, for the first place you get 5 points, for the second place you get 3 points, for third place you get 2 points, and for fourth place you get 1 point. So the scoring system that they give us is a relation. So it can be shown as ordered pairs. The first place is represented by the x. So you have first place, second place, third place, fourth place. And then the points you get is represented by the y. So if we put these in place, we can see there it's set up as a table. Here it is set up as a graph. And this is a mapping diagram. Okay? So you can see it in all three different ways. So this is a relation. There is a relation between the place you get and the points you get. Okay, and that's represented right here. Okay, a function is a special type of relation that pairs each domain value with exactly one range value. So you always want to check to see if each x has only one y. It's okay for two x's to have the same y, that's okay. But if you look at this one, this has two answers. So this is not a function. Okay, each one of these has its own answer. And if you look when all the y's are the same, that means it's a horizontal line. Okay, this one, every x has a different, or the x's are all the same, and they all have a different answer. So this would be, if you look at it, 1, 2, 3, this would be a vertical line. And we'll explain in a little bit why a vertical line is not a function. Okay? Okay, so on page 59 in your journal, they're going to have you describe a function. And I'm going to do these things a little bit out of order. The first one I'm going to give you is the graph. And they didn't provide that, but I'm providing it here. So when you're looking at it, we can describe it by a graph. We can describe it as a set of ordered pairs. And this could be one of our ways that we describe it down here. So I could say, okay, I have 0, 8, and I have 1, 6, okay, and continue on. I could use words for every one x I go up, I go down 2 y's. And I could do an input-output table, which you are all familiar with. You put your x values, so we have 0, 1, 2, 3, 4, and then we put the y that goes with it, so it would be 8, 6, 4, 2, and 0. Okay? And that's how we would describe the whole set if we continued on. Another way is the mapping that you saw on the page before, where you have the number 0, then you point to the, usually they put these numbers in order, so that line would only go to there and not to here. Mapping is different, everybody does it. It's not really common, so you don't really need to study mapping. And now we're going to look at the equation. So that's the big one. So in this chapter, we're going to focus mainly on linear functions. So I'm just going to go ahead and remind you about your best friend, the slope-intercept form of a line. Okay? And this one, we can find the equation. First, we put the y equals, we have an x, and we have to find our slope. So for this one, I can put a little line, and we're going to go into slope a lot more as we go along. But if I look at this, I'm going over 1 and down 2. And my slope is the rise over the run. So since the rise is -2, my slope would be -2. And then my y-intercept is wherever it crosses the y-axis, so it'll be +8. So the slope is this number, the y-intercept is this number. And there's the equation of this line. Okay, so in this exercise in your journal, it asks you to determine whether each relation is a function. So if you look at this, I'm going to look and make sure do any of my x's repeat? And right away I notice that this one does. And these values are different. So that means that this is not a function because one x has more than one y. Again, I look at each of my x's and none of them repeat. So for this set of points, this is a function. Okay, over here, I look and I check my x's and right away I see that this x has 2 y values, so this is not a function. I look over here and for every x, I have only one y, and therefore this is a function. Okay, so those are the kind of things you look for when they're asking you, is this a function? Okay, that was from your journal. Okay, so these are just some rules you need to remember. So a function is a linear function if it's in this form. This is the same as slope-intercept form. This is just called function form. When they put the f of x instead of the y, it is called function form. Okay, so function notation is when a function is defined by an equation that looks like this. This is the xy notation. This is going to be the one we use the most. But if you're asked to give the function notation, just substitute f of x for the y. So what in the world does this mean? Let me show you. Okay, so if it says find the f of 0, it's saying, notice that it's an x in there, it's saying find the answer for the function when x equals 0. This is the function, okay? Find the value of the function when x equals 1. So we could make a little t-chart and we plug in the 0. So we go 2 times 0 is 0 minus 3 is negative 3. 2 times 1 is 2 minus 3 is negative 1. 2 times 2 is 4 minus 3 is 1. And so each time I'm plugging the value of x into the equation where x is, and I'm solving the problem. So 2 times 3 is 6, minus 3 is 3. Okay? And then it's just saying another example. The f of 5 equals 3x plus 2 means find the answer for the function when x equals 5. So you just plug it in. The f of x is not used to find your solution. It's just telling you what to do. You plug the x in here and you get this answer. Okay, you plug the 5 in and solve. Okay, so in this one they're asking you, is this a function? And it's asking you by the number of wheels. So this one has no wheels, and we just look and see, does each one have only one y answer? Remember, it's okay for two different x's to have the same y, but it's not okay for x to have more than one y. So this is not a function, but this is a function. Okay, they can share a y. Okay, so right now we see, hey, this is a function, but let's add another car. Let's add a big semi. We're just going to call this a semi. Okay, and there's all sorts of semis, and so when we do that one, suddenly we find out, oh, it's not a function anymore because the semi has a bunch of y's. This one x has multiple y's, so it's no longer a function. Okay, so when we had up to here, we had a function, but when we added this kind of truck, we didn't have a function anymore. Okay, so the main way that people figure out if it's a function is by using the vertical line test. So here's the description of it. Any vertical line will intersect the graph of a function no more than once. So you can put a bunch of vertical lines down your graph and see if it passes the vertical line test. Notice over here, it crosses in two places, so it is not a function. So if I use the vertical line test on each of these, let's see what happens. So, yep, that one's a function. Now let's try the next one. Yes, that's a function. But then we try this one, and we saw that it intersected in multiple places, more than once. Okay? Now we're going to try again, cross this one, and I could see that here, and notice that this goes on forever, so it actually intersected 3 times. So this one is not a function. This one is not a function. And remember I talked about vertical lines before? Well, I can't. A vertical line hits every point on the vertical line test, so a vertical line is not a function either. Okay, so let's go back to the TrackMeet scoring system, which was written here, and we notice that it is a function because we have a different value for every x, okay? But now we need to understand domain and range. So the domain is all of the x values, and the range is all of the y values. So if you look at it, we look at the x's. There is our domain, 1, 2, 3, and 4. And the range is all of the y values. This is on page 62 in your journal. Now, a lot of kids get like, I don't remember which one goes with which. So if you think of these in alphabetical order, and then you go D and R, because that's alphabetical order, you'll remember that the domain goes with X and the range goes with Y. Okay, notice that the domain and range can be written as sets here. This is when you have a discrete graph, which means you have dots. Okay, because it only is represented by the points on the graph. Okay, so the first thing I'm going to do before I give my domain and range is I'm going to ask myself, is this a function? So I look at all of my x values and I say, are any of them repeating? No. Does anyone have more than one answer? No. Each x has only one y. That's another way to say that it's a function. Each x has only one y. Each input has only one output. Okay, now I'm going to look at my domain. That's my x values, and I just write them down and I put them as a set. I look at my y's for the range, and you don't need to, even though 5 has a 0 and 1 has a 0, you don't need to write them more than once, so you just put the different numbers that are in the range. Okay, so first again, I'm going to ask myself, is this a function? So I ask, do any of my x's repeat? No. Does each x have only one y? Yes. So this is a function. Now I'm going to ask for my domain, which is my x's, and my range is my y's. Anytime you want to stop and see if you can do it yourself, then go ahead and do that. Remember, you don't have to write the repeating number twice. Okay, so again, first thing we're going to ask, is this relation a function? So I look at, do any of my x's repeat? And I see right away that this one repeats, so I double check. Oh, it does have a different y, so this is not a function. But I still have a domain and range, so I've got to find it. So again, for the domain, you only have to write the number once, but it's, and so you just write the domains that are there that are not repeated. And the range is all the answers, the y's. And then it explains what we already found out. The relation is not a function because each domain value does not have exactly one range value. The domain value 3 is paired with 2 values. So each x has, one x has more than one y, and therefore it is not a function. Okay, so first ask yourself, is this relation a function? Well, I could use the vertical line test really quick, or I could also pick one value and see that it has more than one answer. So this is not a function. Most of the domain values have more than one range, but it does have a domain and range. So how do you figure out the domain and range when it's a line? So if a graph is a line, you have to express the domain and range as inequalities. So here's a great way to do it. Draw in lines to see the possible domain and range values. So the blue lines represent the domain, okay? So my domain goes from, remember I'm looking at x's, it goes from, let's make this blue, so it matches. Okay, so it goes from here to here. And so I would write it, oh, and then we're going to show the range, and the range goes from there to there. So now we can write them. So if you look again, our x's go from here to here, and so that is represented by x is less than or equal to 3 or greater than or equal to 5. My ranges go from here to here, which is y is 1, less than or equal to that, goes in between those two numbers. And that's how you would find the domain and range for a picture. Okay, so if you were going to give the domain and range for this one, let's go ahead, and I'm going to use the highlighter this time because it might be easier. So I'm going to draw my range first, my domain first, and it goes between here and here. Okay, so all of my x's are between these two numbers. And if I'm looking at my range, that goes between this one and this one. And I'm going to draw, I can't draw a straight line going down, so just know that it's between those two values. So how would I write it? Here we go. So this is the range. It goes from 4, like I showed you, down to -2, okay? And then my domain goes from -3, which is right here, to +2. And because it's a line, it would be equal to, just like it is over here, okay? And because it is, x is in between, then you would write it as an and problem, just like we did in the last chapter. Okay, so stop, push pause if you want to analyze that picture a little bit, but think about it so you understand it, okay? All right. Okay, so here's some practice on page 63, 5 through 7. So you're finding the domain and range. So push pause, I forgot the pause button, but push pause and see if you can do these really quick, and then we'll go on. Okay, so these are the domains and range. I want to talk a little bit about the independent and dependent variable because they haven't done that in the book so much. So the independent variable is always the variable that is on the x-axis. So if your equation is written in y equals mx plus b form, which this one is, then it means the x is your independent value. Okay? And so the independent variable is now the time. Okay, so we're going to put time down here. And then the dependent value is the number of pages. So we're going to put number of pages. So the number of pages depends on, the number of pages printed depends on the amount of time that goes by. If you stop the printer after 1 minute, you don't get any more pages. So that's what they're trying to explain. This is dependent on the other value. Okay? So the domain is 1, 2, 3. All you would have to do to find those answers is plug 1 into the x, and you would get 12. Plug 2 in, you get 24. Plug 3 in, you get 36. We'll talk more about independent and dependent variables later, but just understand that x is usually your dependent or independent variable, okay, because it doesn't depend on anything. Time is 95% of the time the independent variable because we can't control time, okay? All right, so look at the graph of this function and determine its domain and range. So this is something you haven't seen before. This is showing you that the y-intercept is 0. Whenever you have a y-intercept of 0, it goes through this, if it's written in slope-intercept form. But notice that we have an arrow going on. That means this graph is going on forever, which means as time goes on, every single x will be used and every single y. So the domain and range, okay, so They go on forever, and that line represents forever. So the domain is all real numbers, and so is the range. This is really important to understand. When you're graphing, your arrows mean that it goes on forever. Okay? So the ones that appear on the graph are not all the ones represented by the equation. I could put x equals 1,000. What's my y? I would have to plug it in. So I would go 5, so y would equal 5,000. Okay? So those aren't even represented on my graph, but they are part of the equation. Okay? All right, so looking at this one, if you look at this one, I can see that this is going on forever for all the x values. So my domain is going to be all real numbers. But what about my range? Okay, check that out. Look at the graph. Only non-negative y values appear on the graph. But all my x values appear somewhere on the graph. So my domain is all real numbers. We've learned how to abbreviate that. But my y, my range, is going to be limited. It's only going to be y is greater than or equal to 0 because there's no y's down here. So that's the end of this PowerPoint. It's an introduction to functions and relations and domain and range. So read in the book anything else that you want to know about, but you can probably do your homework pretty easy. It's identifying domain and range and deciding if things are functions or not. So good luck with 3.1.